Hello, it is I, SolarLune. Hi. Hey, so it's been a while. So if you're not familiar with who exactly I am, I'm SolarLune. I am a hobbyist indie game developer. I like to make video games, not particularly well, but I like to make them. And yeah, it's been a little while. It's been a little while since the last time I made a actual, like, honest to goodness video on this channel. Most of the time I've been streaming, but I wanted to try making an actual video because streaming takes a lot of time to do, and my internet connection is not consistent enough where I can stream without causing severe discomfort and nausea. So essentially, so I'm going to be making a little update video that says what have I been doing for the past few months. And there's a couple of things. One is Resolv. So Resolv is a kind of like a collision testing and resolution library that I made for Golang, for the Go language, for use with 2D games essentially. You could still use it for basically a 3D game with just 2 dimensions of movement or collision testing, but it's mainly used for, it would be made for 2D games. And I made this because but rather collision detection is something that every game basically needs in some respect, and very few games need an actual physics engine, even though many people use actual physics engines in their games, like Bullet, Fox 2D, Chipmunk 2D, Havoc, whatever physics engine comes with Unity and Unreal. That's the default, what most people use. But most games are fairly simple to the point where you don't really need any advanced physics to make them. So that's kind of where I'm coming in here with Resolv. When you're starting with a blank slate making a game, it's one of those things where you either go with the physics engine and then have to rip out everything that you don't need, or you're starting with nothing and you have to do everything yourself, and it's like, well, why don't I just make it easier to start each time I start? It's like I don't need friction, I don't need all restitution, I don't need all this stuff that a physics engine has to have physics in my game, because I can do the physics. I just need it to know what to do when stuff is touching, basically. So that's kind of where this is coming in. That's what Resolv is all about. Allowing you to make your physics in your game easily while not being the physics engine itself. So I'll go over kind of a little example of this. This example is up on the repo for Resolv, which is open source. And you can find the tests there. They're all available for download for perusal. So in this example, you can press up and down to spawn or get rid of these little bouncing squares. On my current computer, I think I can get up to around 600 squares at 60 FPS, which is pretty good. That's pretty good. It's going to be a little bit slower now because I'm recording, but it's still not bad. And there's still quite a bit going on. Each square is bouncing off the physics objects, or rather the scenery in the world, but also the physics objects themselves, the squares themselves, which is cool. Very nice. And the actual behavior of this is not something that a physics engine is programmed to do. It's all just the code to test for collision, resolve against those collisions, and then just the basic physics of bouncing. In the second example, and I'm changing these using the number keys, you can basically just have a quick little simple test to see, like, oh, are you in another shape? In the third one, we have circles, so you can see, if the edge of the circle is in another shape or not, which is nice. Circle versus circle, circle versus square, the basic stuff like that. And then past that, we have a thrash test, which is basically something to kind of help benchmark here. On my computer, we have 8,000 moving objects resolving in a space full of 1.5 million shapes. And I'm getting 22 FPS right now. That's pretty good. I think that's pretty good. Yeah, so it's not bad. And these resolutions are only on one axis, or are they on both the X and Y axis? They are on both the X and Y axes. Okay, so that's a total of 16,000 resolutions applied against 1.5 million different objects per resolution. Not bad. Let's see here. Now the next thing we have is line collision testing, which is basically you click to place the line, and then you can just use it to cross. Oh, whoops! I triggered the FPS. Sorry. There's a couple of function keys, F2 and F3, to change the FPS, just to make it a little easier to see if something's going wrong with the physics, not the physics, but the collision testing. So anyway, this is just basic line collision interaction behavior. This square on the bottom is comprised of lines, so basically line shapes, and this square up here is a rectangle shape. So the difference is, because these are just ordinary lines in the shape of a rectangle, you can actually put your line in the middle and you know, cast about freely. But over here you can't do that because it's actually inside of the rectangle. So it's kind of got a little bit of a concept of being inside of a shape versus being between shapes, as in a sense. Let's see here. This is a little platformer test where you can run up ramps, which is very nice. You can jump through certain objects, and you can not jump through others. And you have a little floating platform that you can ride really easily, really buttery smoothly. That's pretty crazy, because a lot of games have problems with this. And I don't mean like professional games, I mean just a lot of games people may have made over the years. I mean, the number of Sonic fan games I've played where you jump and you land and your momentum comes to a dead stop is more than several. Like, it's Multimedia Fusion, the Games Factory, whatever they were using, it wasn't whatever core template they were using for Sonic games with those engines. It just constantly did that. So anyway, it's nice to see really nice, easy, buttery smooth movement. Like, really nice, really easy. No real errors or problems. I guess an error you could say is being able to kind of go back onto a ramp. Like, you kind of like slide up in a sense and kind of like save yourself if you're about to fall off. But that's not really a huge deal. Little snaps like that are a little out of the ordinary, but not too hard to not too big of a deal or too hard to resolve either, I don't think. Yeah, and then lastly we have a test for compound collision, which is basically the ability to kind of do parenting slash make a shape up out of smaller shapes. So basically, as I touch these green objects, they're becoming part of my player object, and yeah, I can now use them to touch other things. And that's the general idea. If I press space, I can undo that and lose them essentially, and then go back and touch them from another angle or in another order. So it's just a pretty basic test just to try out, like, oh, can I do some sort of basic, you know, kind of comprise a more complex shape out of smaller shapes or differently sized shapes. And yeah, unfortunately, there's no line versus circle collision just yet. But that's the basics of this library, and the reason why. And I have little squares. Just in case someone wonders, I have squares here for these rectangles, but they can, you know, of course, be any size rectangles. It's just I just chose squares. But yeah, these are just ordinary rectangles. But now the reason why this is kind of a cool thing is because when you look at the core code that makes it work, this is basically it. Like, as for the platformer example, this is essentially it. I have the floating platform code in here as well. You know, you could disregard that, but like the actual mechanics of walking up ramps, landing on ramps, you know, bumping against walls and the ceiling is all in this, like, 160 in these 80 lines of code. Like, there's so little here to make it work, and that's pretty bananas, because even like you might, if you wanted to make a platforming game, you might go to like the Game Maker asset store or something like that and get a platforming engine, and that would just be for platformers. But this is just like allowing you to do the thing that everything resolves down to, which is check to see if I'm touching something, check to see how far I need to move to touch something, and that's it. And that's what makes it work. That's the same thing for this code here with World 1, with the first test, with the bouncers, where they bounce around, they bounce against each other, they bounce against the walls. This is it. We loop through the bouncers, we add gravity, we limit their speed, and then we try to do the resolve testing, the physics, not physics, but the collision resolution based on their rectangle, their shape, and the speed that they're trying to move. And then if it is colliding, then we move basically to contact with whatever they touched, and then reverse the speeds so that they bounce. And that's literally it. And now you have this almost a physics simulation. Like you could easily make it become a physics simulation. And if you wanted to add something like, oh, well, let's say we wanted restitution and friction to the point where every time it bounces, it gets a little bit weaker, right? So instead of multiplying speed by -1, we multiply it by -0.9. So now it will slow down as it bounces, and that's it. And it's like, you can definitely use a physics engine if you need realistic physics, if you need real physics that do real things. But if you, I didn't actually save it. That's why I'm like, why isn't anything happening? I didn't save it. If you need, a realistic physics engine with realistic physics for your game, please, yeah, that makes sense. Go ahead and do it. But if you need just like something really basic, you could just do something really basic. I think that there's something to be said about doing more with less than doing less with more. A lot of people, a lot of developers would start off with something that they don't need and take out the stuff they don't need, and then add to that something else that they don't need and take out the stuff that they don't need, rather than going the other way and starting with something that they basically starting with nothing, making what they need, and then choosing another framework that just has what they need, and then building on that, and just building what you need on top of what you have, rather than starting with way more than you need and cutting down and trying to cut down. Because I feel like that subtractive approach, it's not going to give you, you're always going to be fighting against something, right? Because if you are making a game with Box 2D or Unity or whatever, not Unity, but Bullet or whatever physics engine it uses, it's going to be made more so for a realistic physics or more generalistic physics simulation over an arcade game, where we don't need to simulate everything, or we might want to simulate some things and not everything else. So it's nice to have that kind of control and that kind of ability to design and make your product exactly as you want it to be made. Yeah, so that's basically what I've been working on. I guess I could talk a little bit more about it, but I already recorded this once and it was like 30 minutes, so I'll just keep it basically a little bit shorter this time and keep it to around this length. As for the other thing, I made a Discord server, so you can actually join this Discord server, and see me make stuff and see the and interact with each other about making games and programming and stuff like that, and that's fun. Yeah, that's always nice to be able to have somewhere you can kind of talk about making games and things like that. But yeah, that's basically what I've been working on. That's basically where I am, and apart from that, that's what I've been working on so far. So yeah, if you want to check out Resolv, please feel free to check it out. I'll put a link in the description. Same thing with the Discord server, and yeah, I guess that's really just about it. So thank you very much for watching. I've been SolarLune, and I'll catch you guys on the flip side next time. See ya.